This is AP Calculus 7-3, sketching slope fields. And first of all, we need to understand what a slope field is. A slope field is a picture of what a differential equation would look like for a specific number of points. So this is an example of a slope field, and we have done this slope field for all the points from your x values being -3 to 3 and your y values being about -2.5 to 2.5. And a slope field really just finds the slope of every particular point within a certain region of the coordinate system. And in order for them to get us to draw slope fields, now when you see computer generated slope fields, they have a lot more slopes, a lot more little dash marks than what we're going to be responsible for. If we were to do this example, they would give us these ordered pairs. They would give us, I've drawn in green here, the ordered pairs that they would give us to find the individual slopes for. You can see we won't have to have all of these marks that they have. But we would have to have a significant number. It looks like we've got probably 18 places here that we would have to draw a mark to signify the slope. And basically a slope field is just a little dash that represents the slope at a specific ordered pair. And the idea is that if we pick one ordered pair within that slope field, and then we draw the actual equation or the actual function through that ordered pair using the slope field as a guide, we can get a good idea of what this function should look like at a particular point. Now remember, when we're dealing with differential equations or when we're dealing with antiderivatives, remember we put in the plus c, and that plus c had to be there because we didn't know what whole number or constant could have been at the end of the function. Well, by identifying one particular ordered pair, we have then identified exactly where that constant would have to be within a particular differential equation. And so this is a very, very general graph of what a differential would look like. But if they ask us for a particular solution, we're taking it down from a very general standpoint to one specific function that we can find using that ordered pair to give us a specific solution or a particular solution through that ordered pair. Here is an example of a slope field where a particular solution has been drawn. They picked a particular ordered pair, and we could say maybe they picked this ordered pair right here. And then once they picked that ordered pair, they used those slopes within that slope field to determine exactly where that line should be. And you can see that they have kind of hugged these slopes. They've made this line match the slopes of those slopes within the ordered pairs of the slope field, so that we can kind of see how gradually this slope increases and decreases. We can see where horizontal tangent lines may have been, or vertical tangent lines may have been, or maybe where the function is undefined. Here's another example of a slope field where they have drawn in 3 separate particular solutions. And you can see that depending on where you pick your ordered pair to be for your particular solution, that graph is going to go vertically up or down, because a particular solution is going to change exactly where your graph will be drawn within the slope field. Now, the good news is with slope fields, we don't usually have to draw a particular solution. And if we do, it's okay to be very general. As long as it matches fairly well, it's not going to have to be perfect. And that's nice, because anytime we don't have to have a perfect answer and we have a little wiggle room for what the actual answer is and what they count right, it helps us out a little bit. So here we have a coordinate system, and it goes from -3 to -2 all the way up to 3, 2. And notice they have put ordered pairs in here for every integer ordered pair within that range. And what they want us to do is they want us to draw the slope field for the differential equation dy over dx equals y minus 1. So what we're going to do is make a chart, and that chart is going to include all of these ordered pairs. And then at each particular ordered pair, we're going to draw just a little teeny dash that represents the slope. So if my slope is 0, then I would have a horizontal line on that little line. If it's negative, it would go in this direction. If it's positive, it would go in this direction. If it's vertical, it would go straight up and down. Keep in mind, if you have a slope that is a fraction like maybe 1/3 or 1/2, it's a very gradual slope. But if you have a slope that's maybe 2 or 3, it's more steep. So you have to account for those things as you are doing your slope field. So what I'm going to do is I'm just going to draw my chart, and my chart is going to organize the information, my x's and my y's and my differential equation, to see what the particular slope will be at each specific point. So here I've drawn in all the ordered pairs on this line on the x-axis. So -3, 0, -2, 0, -1, 0, 0, 0, 1, 0, 2, 0, 3, 0. I'm going to do this for each of these 5 lines. And what I'm going to do is I'm going to plug in to this differential equation to get a slope for each individual point. So the good news about this is the only thing we have to worry about is the y number in each ordered pair. And since all of these y values are going to be the same, aren't all of these going to be the same as well? So if I do this, 0 minus 1 is -1, and that would be my slope for every single one of these. This one's not quite as difficult as some of them are, because some of them would require you to do 7 math problems for each one of these. But we know that the slope at each of these individual points is -1. And so I'm going to just draw a real simple slope that is about the steepness of what -1 would be at each of these lines, because we know the slope of each of these was going to be, or is going to be, -1. So I've drawn the slope field for the points that are on the x-axis. So the next thing I'm going to do is I'm going to get rid of all of these y values and put in the next ordered pairs. It won't let me copy this to go to another page, so I'm just doing it this way. It'll take me a little bit longer. So I have gotten rid of all of the y values here. I've kept my x values. Now I think I'm going to go do this line. So all my y values here are 1, so I'm going to put 1s in here. And good news still, this is our differential equation, so the only number we need to worry about is the 1. And if you plug these 1s in, we're going to get zeros for all of these. So the good news about this one is all of your y values are going to be the same in each horizontal portion of this graph. So it does make it a little bit easier to draw this slope field. So the slope field, all of these lines are going to be zeros, or the slope of the lines here are going to be horizontal. So I draw little horizontal dash marks on each of those lines. I think the next line I'll do is this -1. So I'm just going to make all of these negative. And so hopefully you see what I'm doing. The slope at -3, -1 is what I get when I plug -3, -1 into the differential equation. Well, the only number I have to worry about is plugging in -1. -1 minus 1 is -2. So the slope of the line at -3, -1 is -2. Now that's steeper than this one slope. I'm going to make that slope a bit steeper. It's not vertical, but it is more steep than this one, the -1 was. And if you think about that, all of these are -1s. So every one of these numbers are going to be -2 when I plug in to that differential equation. And if you can find patterns like this as you're drawing your differential equations, it does make it a lot easier. So I need a slope of -2. I need it to be very close. There's going to be room for error. There's no way around it. A couple of these may not be quite steep enough, but just do the best you can with that. I'm going to be lenient. The main thing is making sure they're going in the right direction. If it's horizontal, it's got to look horizontal if the slope is 0. If it's vertical, it's got to look vertical. If it's 1, it's kind of a mid-level slope. If it's something like 1/2, your slope is going to be less steep. And it's really easy for me to tell if it's supposed to be positive and you write it in as negative. Things like that are very easy to grade. So you just need to be very careful about your signs, zeros or horizontal lines, and your verticals or your undefined lines. Next, I'm going to do the y = 2 line. And again, all of the values over here are going to be the same. 2 minus 1 is 1. So all of these are going to have a slope of 1 at each of those points. So my slope of 1 is something like this. I'm drawing 1 in for all of these. So again, if you can find a pattern within this differential equation that's going to make it easier for you to solve, then that will be great. And then the last ones I'm going to draw in are the ones where your y values are -2. If I plug -2 in for all of these y's, I would end up with a -3. So every one of these will be -3. And a -3 slope will be a very steep, even steeper than the -2. So I'm going to say it's going to look something like, and again, it's not going to be perfect. Just do the best you can when you're drawing these. And also, we're drawing them on a computer. So, it's a lot harder to draw things like this on a computer than it is to just do it on paper. Just be real careful when you're drawing. So there's the first slope field. Next, I want to do one where the differential equation involves an x and a y, because I want you to see how that affects the patterns and things. Again, anytime you can find a pattern for these, it does make life a lot easier. So in this one has a negative y over x. I'm going to do the same thing. I'm going to do my xy chart. And then over on the right side, I'm going to put in my differential equation, negative y over x. And then I'm going to take the ordered pairs. Now, think about what happens here if x is 0. Wouldn't my slope be undefined if x is 0, because we can't have 0 on the bottom? So those are the points I'm going to deal with first. I'm going to deal with all of the ordered pairs that have an x value of 0. So those will be all the ordered pairs on the y-axis. So I'm going to put in 0, -2, 0, -1, 0, 0, 0, 1, and 0, 2. I'm going to find those slopes for these ordered pairs first. Well, if I do that, does it matter what the top is? Does it matter what y is? If the x value is 0, aren't all of these slopes going to be undefined? I'm just going to use UN for undefined rather than writing it all in every time. Okay, so all of these are undefined. That means my little slopes here for my slope field, there are going to be little vertical lines. They are undefined. So those aren't perfect, but you can tell that they're supposed to be vertical. Okay, so I think the next thing I'm going to do is I'm going to deal with any y value being 0. Because if I have 0 up here, wouldn't that give me a 0 slope down here? So how do I get 0 here? Well, I have to have a 0 on top. So let's talk about any of the ordered pairs that have zeros as their y values. So we would have those ordered pairs on the x-axis. So if I plug those in, I would have 0 over -3, then 0 over -2, then 0 over -1, and so on. So every one of these is going to have a slope of 0. So again, patterns. If you can find a pattern, it will help these go faster. So all of these have slopes of 0. And now we're going to be dealing with each of the 6 ordered pairs in each of the quadrants. And so at this point, I think I'm just going to leave that -3, -2, -1, 1, 2, and 3. And because we've already dealt with all the ones that have zeros. And I'm going to use these ordered pairs. So like -3, 1, -2, 1, -1, 1, 1, 1, 2, 1, 3, 1. You see the pattern I'm using here. Here, the y values are 1s, and the x values are these numbers. So if I plug 1 in, I have -1 over -3 is 1/3, a positive 1/3. -1 over -2 is a positive 1/2. -1 over -1 is 1. -1 over 1 will be -1. -1 over 2, -1/2. -1 over 3, -1/3. You see how these are time consuming? There's no way around it. At least you won't have too many problems to do. So at -3, 1, I have a slope of positive 1/3, a positive 1/3, and it's going to be a very gradual slope because fractions are gradual. So that's a positive 1/3. -2, 1 is a positive 1/2. So that one's a little less gradual, but honestly, it's going to be very, very hard for you to tell which one's 1/3 and which one's 1/2. So just do the best you can there. -1, 1 is a slope of positive 1. So that is a little steeper than these two. 1, 1, a -1. We'll say that's -1. 2, 1 is -1/2. That's more gradual. 3, 1 is -1/3. Again, very gradual. So there are the ordered pairs in that line. Let's go up here to the 2 line. These are now going to be 2s. And let's think about how that affects things. This would be a -2 over -3. So wouldn't that be a positive 2/3? This would be a -2 over -2, right? So this is going to be a positive 1. This would be a -2 over -1, which would be a positive 2. And you can see how I can just fill this in real quickly. This would be a -2 over 1, which would be a -2. That would be a -2 over 2, which would make this, let's see, -2 over 2 would make this a -1. And then if you plug 3, 2n, negative 2 over 3, so that would be a negative 2/3. All right, so at negative 3, 2, a 2/3 slope. Oh, I'll say it's about like that. Negative 2, 2, a 1 slope. Negative 1, 2 is a 2 slope. That's going to be more steep than a 1, so it's something like that. These are gradually getting steeper as we go toward the right. Then over here, 1, 2 is a negative 2, very steep negative slope. 2, 2, less steep negative slope. And then 3, 2, a little bit less steep negative slope there as well. All right, let's change these to the negative numbers. Let's just go with negative 2 first, since I've already got 2's in there. That'll save us a little time. Minus the negative 2 is 2 over negative 3, so that'll be a negative 2/3. This will be a 2 over negative 2, which would be a negative 1. So it looks like these are all changing their sign. That would be a 2 over negative 1, which is a negative 2. That would be a 2 over 1, which is a positive 2. That would be a positive 2 over 2, which is a positive 1, and then this would be a positive 2 over 3, which is positive 2/3. So all the signs changed here. So at negative 3, negative 2, we have a negative 2/3. And this is our last line, and you can see this is tedious. There's no way around it. Sorry about that. So we're doing our negative 1 line. Negative 3, negative 1, negative 1/3. That's a very gradual slope that is negative. So something like that. Negative 1/2 again, very gradual slope that is negative. 1, negative 1. This one is a positive 1. 1/2 is 1/3. There is my slope field. It's tedious. There's no way around it. I don't know how to save you time on this. It'll be faster for you because you're doing this on paper. But there's no way around it. You just have to find the slopes at each of these individual ordered pairs. And again, if you can find a pattern within the ordered pairs, it will save you some time. The next thing they're going to ask us to do is they might give us some slope fields and ask us to compare the slope field with the differential equations. Figure out which of these slope fields go with these differential equations. Now, what I do for this is I will go into the individual slope fields and I will pick points like where the slope is horizontal. So like here's a good example right here. This slope right here is horizontal. So I'll say that's at 0, 2. Okay, I'll say this is the line 0, 1, 2, 3, 4. See what I'm doing? So 0, 1, 2, 3, 4. So if this is at 0, 2, at the ordered pair 0, 2, my slope is 0. So I want to go down here and see which of these give me a slope of 0 when I plug in 0, 2. Well, let's see, sine at 0. Well, sine at 0 is 0, so we can't throw that out. That might be a possibility. Here, 0 minus 2, that would give me a slope of negative 2. So we can eliminate that for part A. Here, 0, 2, if I plug 2 in for y, I do get a 0 here. So that may be my answer. Very possible. So we've got 2 of them so far that might work. If you plug in 0, 2, well, 0 in for x gives me a 0. So that very well could be the answer as well. Okay, so we've eliminated 1. Let's pick another ordered pair in here. I don't see any ordered pairs that are vertical. That would be my next choice, is to find ordered pairs that are vertical. I don't see that, but I do see that all of these ordered pairs at negative 3 are very steep positive slopes. So let's plug in 0, negative 1. All of these lines at negative 1 have very steep positive slopes. So let's plug in maybe let's just do this point here, 0, negative 1, and see what happens. Well, if I plug 0 in for x, I get a slope of 0, right? Not a very steep positive slope. So I can eliminate 7. When I plug in 0, negative 1, well, 2 minus negative 1 is a positive 3. Well, a 3 would be a pretty steep positive slope. So I can't eliminate that one. If I plug in negative 1 here, well, if I plug 0 in for x, I get a 0 slope. So it can't be 10. So my answer here, this one has to be 9, because both of the ordered pairs that I picked worked for number 9, and that was the only one they worked for. So let's move on to B. So we don't have to check 9. We know 9 is A. So I'll put A right here. So for part B, we only have to check 3 of them. All right, I'm going to pick horizontal slopes here. All of these, all of your X values here are 0. So when I plug in the X value for all of these, I should have a 0 slope. So let's just see if we can find one where that works for all 3 of these ordered pairs. 0, 0, 0, 1, and 0, negative 1. Well, if I plug 0, 0 in here, sine of 0 is 0. All right, that works. And all of these for sine of 0 would give us a 0 slope. So we cannot eliminate 7. All right, let's look here. If I plug 0 in for X and 0 in for Y, we get a 0 slope. That works. If I plug 0 in for X and 1 in for Y, I get a negative 1 slope. We can eliminate 8. It can't be 8. If I plug 0 in here, they do all give us 0 slopes. So it could be either 7 or 10. All right, let's pick some other ordered pairs. I don't see any vertical slopes, but I see some that are very, very close to vertical. Like if I go over here and I'll let my X value be 1, 2, 3, 4, 5, 6. If my X value is 6, I get a very steep positive slope. So I'm going to try 6, 0, 6, 1, and 6, negative 1. They should all give me the same very positive, very steep positive slope. Well, if I plug 6 into sine x, we have no way of getting that answer. You could plug it in the calculator, but I doubt very seriously this is going to be a sine function. Look at 10. If I plug 6 in, I get 6, a very steep slope. If I plug 6 in here, 6, a very steep slope. In fact, if you think about this, wouldn't the slope we get here be the same for every x value? So whatever the x value is what the slope would be. Well, let's think about that. The x value here is 1. That looks like about a slope of 1. It's getting a little steeper, a little steeper, a little steeper every time we go to the right, which would make sense if we have the positive slopes. If I negative 1 here, negative 2, negative 3, that's very possible that these are the slopes that we're plugging in for the x value. So that B would be 10. Look at C. Well, I don't know about you, but that to me, if I were to try to draw a particular solution, look at this curve I'm getting when I just follow along with the slopes here. What's that look like? Looks like it might be a sine curve to me. Okay, so you can kind of tell what the directions of the slopes are telling you to do, but we can check it to be more exact. Let's double check. Whenever x is 0, our slope will be 0, correct? And that's what we're getting here, slope of 0. If we plug in 1, sine of 1, wouldn't these slopes be the same every time? So this is my best bet. 7 is my C. It's got to be C, just by elimination of the way the pattern is going. And so then let's look at 8, and let's look here and see if we get some matching slopes. I'm just going to pick 3 random points. Well, first I want to pick 0, 0. It looks like that's a slope of 0. 0 minus 0 is 0. Yeah, that matches. Look right here, 1, 0. Well, it looks to me like that's a slope of about 1. So 1 minus 0 is 1. How about at 2, 1? So look at where the 0 slopes are here. Doesn't that look like there's another one at 1, 1? Well, 1 minus 1 is 0. At 2, 2, 2 minus 2 is 0. At 3, 3, 3 minus 3 is 0. It looks to me like that's where our horizontal slopes are, and the only one that matches that would be 8. And it's a process of elimination, but that does match. We just need to pick a few points to see what happens. So now I want to look at delta math. I want you to see how to draw slope fields in delta math. You're going to do a section that is slope fields multiple choice. That's fairly similar to what we just did in that last example. But they might ask you to create a slope field. And notice here, they have given you little lines. And it looks to me, and this is nice, they only give you 9 points to deal with. So you don't have to deal with so many points at a time. But what you're going to do is these ordered pairs that are in yellow, you're going to plug in for x and y here to figure out what your slope is. And then you're going to manipulate these so that you can turn them to be, whatever you want for the slope. So if the slope is 0, you would go horizontal. If it's vertical, you would go vertical. Negative 1 would be like halfway. 1 would be halfway. The less steep you make it, the more likely it is a fraction. The more steep you make it, it will be a whole number type slope. So, and they're going to be very lenient on how to draw these. So Let's just start with 0, 0. If I plug 0, 0 in, I have negative 1 squared is 1 times 1 is 1. So the slope is 1. I would say that's pretty close for 1. For this one, 0, negative 1. Well, if I plug negative 1 in here, isn't that going to give me a 0? In fact, anytime I plug negative 1 in for y, I'm going to get a 0 here. So wouldn't that force all three of these to be 0 slopes? So there's a pattern that helps me with these three. And you can double check. 2, negative 1. Well, negative 1 gives me a 0 here. 2, that's a 1 squared is 1 times 0 is 0. So all of these are going to be zeros. We've done this one. Let's go to 1, 0. Well, if I plug 1 in here, look what happens. Anytime x is 1, doesn't that make this 0? So wouldn't this one be 0 and this one be 0? Anytime we plug a 1 in, we're getting 0. So let's go to this point. We haven't done it yet. 0, 1. If we plug 0 in for x, we get negative 1 squared is 1. 1 plus 1 is 2. So 2 times 1 is a 2. So that's a steep positive slope. I will say it's about right there. And then the last one, 2, 1. If I plug in 2 for x, I get 1 squared is 1. And then 1 plus 1 is 2, so 1 times 2 is 2. So again, that's a steep positive slope. I'm going to make it steeper. And that's as close as I can get. There's really not a whole lot more I can do with this. So I'm going to submit the answer. If it's wrong, they'll tell me where, I think. And if it's right, they'll say you're good to go. And we got that right. Now notice here, I didn't quite make this line steep enough, but they're very lenient about that. That's okay. The main thing is that you understand if it's a whole number, it's going to be steep. If it's a small fraction like 1/2 or 1/3, it's going to be a lot less steep. All right, let's go to one new problem. This time I'll get one wrong on purpose to see what happens. So let's see, if we've got 0, 0, if I plug 0 in here, negative 1 squared, oh, well, division by 0, that makes that vertical. So that's going to be vertical. So if my x is 0, these will all be vertical. All right, if x is negative 1, this is negative 1, 0. Well, that's going to be a 1 on top, negative 1 on bottom. So 1 over negative 1 is negative 1. So I'll make that a negative 1. If I plug negative 2, 0 in, 0 here gives me a 1 on top, negative 2 on bottom. So 1, negative 2, that's a negative 1/2. Okay, negative 1/2 is a very gradual slope, negative. So very gradual negative slope. Negative 1, 1, if I plug negative 1 in, well, 1 gives me a 0 here. In fact, both of these y values will be 0. These are both going to be 0. And then if I plug in negative 1, 2, both of these y values are 2. So on top, for both of these, we're going to have a 1. On the bottom, it's whatever the x value is. So 1 over negative 1 would be a negative 1. And then 1 over negative 2 is a negative 1/2, a very gradual. So there's a negative 1/2. Now, I said we were going to get one of these wrong. Okay, so I think all of them are right. Let's make this one right here at 0, 0 wrong on purpose. We know it's supposed to be vertical, but let's make it 1 and see what happens. Let's see what they tell us when we get something wrong. Yes, I'll submit, and it tells me I'm wrong. And you can see here it tells me why I'm wrong right here. It puts a red mark there. These were close enough. They're not going to squabble over that little bit, but this one was obviously wrong. I said it was a slope of 1, and it should have been vertical. And then another thing that I'll ask you to do in these is to do slope fields multiple choice. So they'll give you a slope field, and you'll have to figure out which of these is the best solution by plugging in some specific ordered pairs. And I would look for patterns, like all of these are zeros. So figure out which of these, when x is 1, which of these would cause all the x equals 1 lines to be 0. That's it for slope fields. Hopefully you've got enough. I know this can be very tedious.